Hello viewers, hope you are doing fine. This video shall be session 2 on combining tables topic, and we are going to cover the balance 3 mutating join functions from the Dplyr package. Remember, we are discussing the mutating joins from the Dplyr package. In the first session we covered some basics and use in a join to combine the tables. If you are watching this video for the first time directly, I would highly recommend you to have a look at my previous video and come back to this one. This will help you to put all the things in proper perspective. I've also given the part 1 video link in the description. You may go and check it. So let's start with the left join. Left join. Left join keeps all the observations in data frame 1 and matching observations in data frame 2. Okay, so as you can see in the picture here, left join returns all the rows from the left data frame and any matching rows from the right data frame. So the unshaded part, this white region, are the observations dropped by the left join. Okay, so let me pipe in employee table into left join, and second data frame will be the employee department as a joining entity. So employee department, here the key column will remain the same, the employee ID. So let me use that in join by method, employee ID. So let's have a look at the output. So it has printed all the observations from employee table and all the matching values from employee department table. Yeah, so you can see that the last 3 observations, there are no matching values in employee department table. Remember, the last 3 employees have not allocated to any department. As we saw earlier, these non-matching observations are printed as any values. The second point here to be noted here is that there is no data loss because all the values from the employee table are printed out. Okay, so there is no data loss while using the left join. Now in the left join, is the ordering of the table important? Let's see. Now let me flip the order of joining. So instead of piping in employee table first, I will pipe in employee department first, followed by employee table. Let's see what happens. Join by employee ID. So the output now, the output indeed has changed and we got 7 observations now instead of 10 earlier. And because the ordering has changed, now all the observations from employee department table are shown. Remember, we are using left join. And only the matching observations from employee table are displayed. So did you see how important the order of joining the table using left join is? So always be mindful about joining order of the tables using left join. Okay, so you have a left join, you should also have a right join. That should come natural. In right join, keeps all the observations in data frame 2 and matching observations in data frame 1. Okay, let's see. So right join returns all rows from the right data frame and any matching rows from the left data frame. So the unshaded part here that you see are the observations dropped by the left join. So let me first pipe in employee table data into right join. And the second table I'm going to use is a course enrollment table. Okay, course enrollment table. The key column in this case shall be employee ID, so I will use a join by method. But there is a small issue. We are going to face a small issue here. What is that? The key columns in these 2 tables, the name of the key columns in these 2 tables is not the same. In employee table, the name of the key column is employee ID, while in course enrollment table, the name of the key column is employee number. So what are we going to do now? So in this case, we will have to use equality operator, and we'll have to explicitly tell R which key columns are to be matched from both these tables. So join by, I'm going to use the key column from employee table, which is employee ID, equality operator equal to, and the name of the key column from course enrollment table, employee number. So let me execute this. Yeah, now we got the output. Yeah, now if you see the output now, it has printed all the observations from the course enrollment and all the matching values from the employee table. Remember, we are doing a right join. So all the observations from course enrollment are printed and all the matching values from the employee table. Fine, coming back to our question. In the right join, is the ordering of the table important? Let's see. Let me now flip the order of joining the tables. So instead of piping in course enrollment first, I will pipe in employee table first and then perform right join. Well, it's going to give me the different output. So course enrollment, pipe into the right join, employee table, join by. Now you will also have to take care about similar ordering inside the join by method. The similar ordering of the key columns inside the join by method. Okay, so join by, the first key column name will come from course enrollment table, employee number, and the second key column name will come from the employee table, that is employee ID. So if you flip the tables, you will also have to flip the ordering of the key columns inside the join by methods as well. So let me execute this. Let's see the output. The output has indeed changed, and we've now got 10 observations instead of 4. Because the ordering has changed, all the observations from the employee table, remember we are doing right join, so all the observations from employee table are printed out. And only the matching observations from the course enrollment are displayed with the values, and all other non-matching observations are printed with NAs. Right. Let's perform the full join. So this will be the last mutating join that we'll see. Remember, we covered in a join, left join, right join. This will be the last one, the full join. Full join is very simple. Keeps all observations from data frame 1 and data frame 2. Right? So it will give you all the rows from both the data frames, whether or not they match with one another. That's what full join will do. So let me first pipe in employee table into full join and use the data frame employee department as a joining entity, employee table, pipe into full join employee department, join by employee ID as a key. Right, so let me execute this. Have a look at the output. It has printed all the observations from employee table and all the observations from employee department table. The last 3 observations, because there are no matching values in the employee department table, as we saw earlier, those non-matching observations are printed as NAs. Right? Okay. Now, in the full join, is the ordering of the tables important? The answer to this question should be a no-brainer, because the observations from both the tables are printed out anyways, so it doesn't really matter which order, which table comes first and which comes later in the order of joining. So let's see, let me flip the order. Employee department first, followed by employee table. Let's see the output. As you can see, the output is the same. The order of columns have changed in the data frame. That's okay, but the number of observations are same. The output is the same, right? Doesn't really matter how the ordering takes place when you are working with full join. Okay, so we have come to the last part of the video. So far we have been working with one-to-one relationship. What about the tables which have one-to-many relationship? So let's pretend that we want to combine employee table with the new table now, called project allocation table. The project allocation table will have all the project information that the employee is currently working on. Okay, so this table, employee allocation table, looks like this. So I have this employee ID 12320. It's working on 2 projects, alpha and beta. 15431 working on 3 projects, gamma alpha 1 beta 1. 14290 working on 2 projects, gamma 1 beta 1. Now you can see that the employee IDs are repeated since each employee is working on multiple projects. Now if we want to combine this table with the employee table, how the output will look like. So let's see. So let me pipe in employee table into project allocation. So employee table, pipe into the left join. Now for the sake of explanation, I am using left join. You can also use a right join, should not matter. So left join, project allocation, joined by key employee ID. Fine. So let's check the output. So now what has R has done here? For each key value in employee table, if there are multiple matching key values in project allocation table, okay, all the values in project allocation table are returned. So for employee ID key, only one key value pair is available in employee table. 12320 power, one key value pair from the employee table. However, there are multiple key value pairs available in project allocation table. 12320 alpha, 12320 beta, 2 key value pairs in the project allocation table. Because each employee is working on multiple projects, so R has printed all the matching key value pairs in the final output. Okay? Right. Now you can also check how R will work when matching many-to-many relationships. So I explained one-to-many. You can also do many-to-many relationship that I will left upon you as an exercise. Please check that. So we have come to the video, time to wrap up. That's what I want to say. Thank you very much for sticking till the end. You may like to subscribe to this channel. Also press the like button, hit the bell icon if you want to get notified. I would also appreciate if you can drop your comments, suggestions in the comment section for any improvement in the content. I will be extremely happy to read your suggestions and will try to implement those in my videos. I will see you soon. Take care and goodbye.